in this class, we're going to be talking about a lot of different quantum gates. And so last class, I told you about C0 gates and Toffoli gates and maybe Fredkin gates and AND gates and OR gates, et cetera. So we're doing quantum computation in the circuit model, which means we'll be stringing together bunches of quantum gates. And we need names for all these quantum gates. Or not all of them, but sigma x is 0, 1, 1, 0. Sigma y is equal to minus I, 0, 0. Sigma z is equal to 1, 0, 0, minus 1. H is equal to 1 over root 2, 1, 1, 1, minus 1. And there's two more. S is equal to 1, 0, 0, I. So S squared equals Z. And T is equal to 1, 0, 0, e to the 2 pi I over 4. So T squared equals S. And Seth Lloyd has a great technique, a great mnemonic for remembering which of these is the minus I and which of these is the I. And his mnemonic is your minus I is lighter than I, so it floats to the top. Floats to top. So if you can remember, that it's either minus I or I minus I, this tells you which of the two is the minus. And that's the only really hard thing to remember about this. So what happens when we apply two of these Pauli matrices? What happens when we multiply two of these Pauli matrices? Well, let's do it on the block sphere. And then, so sigma x keeps the x-axis of the same and interchanges the minus y-axis and minus z-axis to units. Sigma y keeps the y-axis unchanged and interchanges the z-axis and the x-axis units. So if you multiply sigma x and sigma y, well, you flip the minus x and x vectors, you flip the minus y and y vectors, and you flip the minus z and z vectors, but then you flip them back. So sigma x times sigma y is sigma z. Except that's not quite right, because we're leaving out signs. So sigma x, sigma y is equal to, actually, I think I sigma z. Let's check that. Sigma x times sigma y, the top left corner is an I, and the bottom right corner is a minus I. So we get I minus I, which is indeed I sigma z. And sigma y sigma z is equal to minus I sigma x, is to plus I sigma x. Sigma z sigma x equals I sigma y. So you multiply two Pauli vectors, you get an I times the third one, assuming you multiplied them, x times y or sigma y times sigma z, or sigma z times sigma x. And then sigma y sigma x equals minus I sigma z. So an important thing is the three Pauli vectors. Well, they anti-commute in pairs. Sigma x sigma z equals minus sigma z sigma x.